Okay, since this is a very important topic, let us take few more examples to understand how we can follow all these steps. Okay, so here is another one. Now the situation is as shown in the figure. On the horizontal surface, mass m2 is kept and a thread is tied between m2 and m1 like as shown in the figure via a pulley. Okay, we need to find out acceleration of m2. Right. Now I know that acceleration of m2, if it is there, will be only on the right hand side. Okay, because this m1 will pull it down the string and it will experience m2 will experience force right hand side, and it can only move if it is along the right hand side. Okay, now if there is a friction, suppose it is given that coefficient of friction is mu. Okay, so we'll solve this problem by solving by making use of all these steps. Okay, we know that in order to follow these steps, we need to pick one mass at a time. All right. So first I will pick this mass m1. Okay. So I can draw m1 separately also like this. This is m1. Okay. Step number 1. Step number 2 says pick a suitable coordinate axis. Now for this mass, I know the forces will be vertical and acceleration is also vertical. So the obvious choice of coordinate axis for this mass is like this. This is my x and this is my y axis. Alright. Now I have to draw all the forces on a mass as arrow so that the tail touches the mass and the head shows the direction of the force. So one is m1g, right? That is the gravitational force. Any other force on m1? There is a string, right? And string will apply tension force on m1. And we have learned that tension always pulls. Okay, it can never push. So the string will pull it up with tension force T. Okay, and if M2 has acceleration A, what will be acceleration of M1? It will also move along with M2, right? If it moves by 1 centimeter, M1 also moves by 1 centimeter in the same time. And if its velocity changes, M1's velocity will also change simultaneously because they are constrained to move in that manner because they are tied with a string, okay, which is inextensible, massless and frictionless. So I'll say that this goes down with acceleration A. Okay, fine. So this is step number 1 to 5. Now step number 6 says identify angles the forces makes with the coordinate axis. Now you see that all the forces, even acceleration for that matter, they are along y-axis. So angle is 0 and with x axis it is 90 degrees. So I don't need to show those angles. Then resolve the forces along axis. Now component of tension and mg along y-axis is the complete force and along x-axis their components are 0. Then step number 8, show acceleration as arrow not touching the mass. So that we have already shown. Okay. Then resolve the acceleration along the axis. Acceleration is already along y-axis. Similarly, like the way we talked about the forces, acceleration also I don't need to resolve. Fine. Then you have to identify the motion constraint. What are the motion constraint here? The motion constraint, there are two motion constraints here. This M2 will move horizontally, that is first motion constraint, and second motion constraint is both M1 and M2's acceleration will be same, and that we have already incorporated when we say this is A and that is also A. Okay. Then I have to write down step number 11, force equal to mass times acceleration along all axes. Okay. So if I write sum of all forces along x-axis is mass time acceleration along x-axis, then I see along x-axis there is nothing, no force is there and no acceleration is there. So I get 0 equals to 0. And if I write down this equation, sum of all forces along y-axis is mass time acceleration along y-axis, what I get is m1g, direction of force along acceleration I am taking as positive, minus t is m1a. Okay, so this is the equation I get from the free body diagram of m1. Okay, let us see what happens with m2. So what I request from you is you can pause the video and draw all the forces on your own, and then you can see how how it can be drawn or where you went wrong. So with M2 there is of course M2G, fine, and there is a string also. String again pulls, so it will pull M2 in this direction. Now what is that string force be? Will it be equal to T? Yes, it will be, because it is the same string. We have learned that if there is a single string, it will have single tension. So this is tension T, this is acceleration A, and there is a friction force. Now, what is the value of friction force? Since M2 we have assumed that it is moving, the friction force will be constant and its value will be mu times normal reaction. So this friction force will be equal to mu times N, and there is another force, normal reaction on N2. Okay? So this one for block 1, this is for block 2. So for block 2, I take my x and y axis like this. This is my x and this is my y. Why I have taken like this? Because you see all the vectors, all the arrows, they are already along x and y axis. So it makes easier for us to assume x and y axis like this. I don't need to take components of any vector if I take like this. Alright. So sum of all forces along x axis, if I write down this equation for mass m2, I'll get t, which is in the direction of acceleration, minus mu times n will be equal to m2 into a. Fine. And if I write down sum of all forces along y direction equals to mass and acceleration along y direction, then I know that acceleration along y direction is 0. Fine. So normal reaction minus m2g is equal to acceleration in y direction is 0, so it is equal to 0. So I have got how many equations? We have 1, 2 and 3 equations. Let us count the number of variables. 1, normal reaction, 2, acceleration, and 3, tension. So we have 3 variables and 3 equations. Now we can solve to get any of these 3 variables values. Okay? Fine. Let us take up another type of question. Suppose you have mass m1 which is kept on a smooth surface, and this surface is not very rigid. Okay, it is flexible. So when you keep mass m2 on it, keep mass m2 on it, this mass m1 starts to move with acceleration a. It goes inside the surface. It's like suppose you keep m1 on sponge, right? And when you keep m2 over it, m1 starts to move with acceleration a inside the sponge. Okay, we need to find out normal reaction between m1, m2, and between m1 and the surface. Fine. So let us draw the free body diagram of m1 and m2 separately. Okay. Let us first take mass m1. So this is m1. Now what are all the forces? There is m1g like this. Okay. There will be normal reaction from the surface on m1. Which direction it will be? It will be normal to both m1 and the surface, and it will be a push. This will be suppose n1. Okay. Now any other force that we have missed. There is another contact surface m1 and m2. Okay. So since there is a contact, there will be a normal reaction. m2 applies on m1. m2 creates a normal reaction on m1. Which direction it will be? Normal reaction always pushes. So m2 will push m1 using normal force, and it will be downwards. Okay. So this is m2. Okay, and it has acceleration a. Okay. Now let me draw the free body diagram of m2 also, and then we can start to solve. Okay. This is m2 which is kept on m1. Okay, it will experience m2g downwards. What else it will experience? What else the force is? m2 is kept on m1, so m1 will push m2. So there will be a normal reaction. What will the value of that normal reaction? According to Newton's third law, every action has equal and opposite reaction. m2 pushes m1 with n2. So m1 will push m2 with same force n2 but in opposite direction. So it will get a push from m1 in this direction. Okay. Now what will be the acceleration of m2? We have assumed that m1 is rigid. Okay. m2 do not go inside m1. They both move together down. So if its acceleration is a, m2's acceleration is also a. Right? Now we see that all the vectors, all the arrows are vertically aligned. So the obvious choice for both xy coordinates are this we take as x and that we will take it as y axis. Okay. So along x axis, no point writing the equation. We'll write equations along y direction only for both the cases. Okay. So let us first write down the equation for mass m1. So along the direction of acceleration, forces are m1g plus n2 minus n1. This must be equal to m1a. Right? This is the equation for mass m1. For mass m2, along the acceleration m2g minus n2 is m2a. Now how many variables are there? There are only two variables, n1 and n2. Value of n2 you can directly get from here is m2 g minus a. Okay, when you substitute the values here, you get it as m1 plus m2 g minus a. Okay. Now there is one more thing that we can do here is since m2 and m1 they are moving together, right? So can I assume both m1 and m2 together as a single mass? They behave like a single mass, right? There is no relative motion between m1 and m2. So let us assume m1 and m2 as a single mass and then see how can we apply the all the free body diagram steps. This is m1 and this is m2. Okay, I'll say that there is a single block of mass m1 plus m2. Okay, so I'll draw it also accordingly. So I'll assume that this is a single mass of m1 plus m2. Both of them, sorry, the single mass accelerates with acceleration a downwards, and this will experience a normal reaction, right, which will be n1 only, which m1 was assuming. Now entire mass, if I take it as single unit, will experience n1, and this will be m1 plus m2g gravitational force, right? So when I write down Newton's second law of equation along y-axis, I'll get it as m1 plus m2g minus n1 is equal to total mass into acceleration, right? So when I simplify, I'll get the same answer for force n1.